Up to now we've only been able to use trigonometry for right-angled triangles, but now we have a special rule, the sine rule, which will help us find sides and angles in any triangle. The first thing that we need to understand about any triangle is the way that we label it. It doesn't have to be right-angled, but we're going to label the corners, the vertices, with capital letters, and we want to label the sides with lowercase letters. And the way we label those is that the side opposite the angle is given the same letter. So in this case, little b is opposite angle B, little c is opposite angle C, and so on. And then the sine rule helps us to work out any missing sides or angles. And you can see here that it's made up of three separate ratios, three fractions. A over sine of angle A is B over sine of angle B, which is C over sine of angle C. This can be also written upside down, as long as we're consistent, but generally we go with this first one. A over sine A is B over sine B, which is C over sine C. So in this example, we're asked to find a side of a triangle that's not right-angled. We're asked to find side A. And because it's side A, I'm going to label the angle opposite it as angle A, capital A. And I'm going to put the other two corners then as B and C. And so I can also label the sides that are opposite those angles. So opposite angle B is side B. So I'm going to write 5.1 is side B. And the other side then opposite C is side C. Now we want to find side A. So we need the part of the sine rule that mentions A in it, so it's A over sine A. But we need to know everything else in that formula. And you'll notice we know angle B is 60 and side B is 5.1. So that's the other part of the ratio we're going to use. A over sine A is B over sine B. We only ever need to use 2 out of the 3 ratios. So once we've got our formula written down, we fill it in. It's A over the sine of 45 equals 5.1 over the sine of 60. We can cross multiply because it's one fraction equal to another. And if we cross multiply each time, it's usually quite a straightforward way of doing this. So A times the sine of 60 is equal to 5.1 times the sine of 45. And then we want to find what A is, so we divide through by sine of 60. Now one thing just to be careful about is these are all in degrees. We need to make sure that our calculator is in degrees mode. And you generally know that if there's a little D at the top of your calculator display. And once I put this all into my calculator, I find that A is 4.16 centimetres. And generally just give your answer to 3 significant figures. In this example, again, we don't have a right-angled triangle, so we're going to use the sine rule. And we want to find this time an angle Y. So the side opposite angle Y is side Y. And so I'm going to call the other sides X and Z. And you'll notice here this time that we know what angle X is and what side X is. So we know the ratio X over sine X. And we want to find angle Y, and we know side Y. So the ratios we're going to use are X over sine X, and we need Y over sine Y. We must have that second one, because we want to find the angle Y. Once we've filled in our formula, once we've written down our formula, we fill it in. So X is 11.4, the sine of X is sine 63, and Y is 12.7. Now again, we have one fraction equal to one fraction. So we can multiply up and across, we can cross multiply. And that gets us then that 11.4 sine Y equals 12.7 sine 63. Rearranging this, we just divide through by 11.4. So sine Y is 12.75 times sine 63, all divided by 11.4. And when we put that right hand side into our calculator, we're going to get a value of 0.9926. I'm going to get it to 4 significant figures here to be more accurate than I need to be at the moment. But this is what sine Y is equal to. And if you remember your normal trigonometry, if we want to find Y, knowing sine y, we use the inverse sine. The reverse procedure of sine is inverse sine. So y is equal to the inverse sine of 0.9926, and that ends up as 83.0 degrees. So here's a problem-based question. We're asked that the angle of elevation of the top of a building from point A is 25 degrees, and from point D it's 15 degrees. And you'll notice that in this we have two types of triangles. We have a right angle triangle and a non-right angle triangle, scalene triangle. And what we're going to do is use the sine rule to help us find a missing side, and then use normal trigonometry on the right angle triangle. So first, let's fill in what we know. If the angle to the left of D is 35 degrees, then the angle TDA is 145. And that allows us to find the angle at the top of that scalene triangle is 10 degrees. Now if we want to find that side TD, I'm going to call it side A because it's opposite angle A. So A over sine A, and we need another ratio that we know. Well, actually, we know angle at T is 10 degrees, and side T, the angle opposite that, is 15 meters, so we know the ratio T over sine T. So let's fill in for this. A over the sine of A, sine 25, is equal to T, which is 15, over the sine of T. We know that that angle is 10 degrees. Again, one fraction equal to one fraction, we can cross multiply. So A sine 10 equals 15 times the sine of 25. And so A is equal to 15 sine of 25 divided by the sine of 10. Again, make sure your calculator is in degrees mode. And because this isn't my final answer, I'm going to be more accurate than I need to be. So I'm going to give this to 4 significant figures. So A is 36.51 meters. I'm just going to mark that in on my diagram here, 36.51. Because now what we're going to do is we're going to concentrate on the right angle triangle here, TBD. And because it's right angled, we can use normal trigonometry. And if I concentrate on the 35-degree angle, then the side TB, the height, is opposite that. And the side we've just worked out, 36.51, is the hypotenuse. So we can use normal trigonometry. Opposite in hypotenuse is the sine of angle x, is opposite over hypotenuse. And we can fill this in. The sine of 35 degrees is the opposite side, which is the height of the building. So I'm just going to call it h for the minute. Divided by the hypotenuse, 36.51. And so to find the height of the building, we multiply 36.51 times the sine of 35. And that gets us what h is. And because it's our final answer, then I'm going to give this to 3 significant figures. So h is 20.9 meters to 3 significant figures. So now it's over to you. Here's a couple of questions that you'll need to use the sine rule to find either a missing side or a missing angle. In each case, you'll know at least one ratio of a side over the sine of the angle, and so that will help you use the sine rule. Just pause the video, and when you're ready to find out the answers, start it again. So how did you get on? Well, I hope. The next in this series of videos on trigonometry is going to be on the cosine rule, which is another rule which helps us find sides and angles of triangles that aren't right angled.